Okay, you ready? Parent functions. So it's our second day talking about parent functions. So if you know the name of it, can you tell me? Do you know what that's called? It's called a quadratic. Okay. Now some people think it's called a parabola because it's x squared, and that's kind of true. The name of the function is a quadratic. The name of the shape it makes is a parabola. Okay. So let's go down here to our table, and we'll go ahead and use our same old. So remember, y equals x squared. So if x squared equals -2, what is -2 squared? What's -2 times -2? 4. So what's -1 times -1? What's 0 squared? 1 squared? 2 squared? 4. Okay? So now let's plot these on the graph up here. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Now, do you think you have a general idea of what this shape looks like? Yeah? Does it stop right here? No, we learned that yesterday, right? It doesn't stop right there. It keeps going, doesn't it? So I'm going to go ahead and draw it in. What is the x-intercept of this function? 0, 0. Very good. And what is the y-intercept of this function? Oh, it's the same, right? It's the same. When it's the origin, we know x-intercept and y-intercept are going to be the same, don't we? Okay. What's the domain of this function? How far to the left does it go? All the way? How far to the right does it go? All the way. So our domain is all real numbers, or it is -infinity to +infinity, right? Inequality notation, interval notation, remember? What about the range? How far down does it go? To 0. And how far up does it go? All the way. So how do we write that as our range in inequality notation? What is true about the y values? Absolutely, greater than or equal to 0. And remember, in interval notation, we have to start with the least and go to the greatest, so 0 to infinity. Does 0 have a bracket, or does 0 have a parenthesis? A bracket, because 0 is part of our range. It touches the axis right there, doesn't it? Okay. Does it have symmetry? Yes, around what? Good, the y-axis. Okay. What is the maximum point? Yep, there's not one because it goes all the way up, right? What is the minimum point? 0, 0. There is a lowest point on this graph, so that is the minimum, right? All right, intervals of increase. Where is it increasing? Remember, that's just when we're moving from left to right. Where is it increasing? On the right-hand side of 0. So it starts at 0 and increases. So it starts at 0 and goes to infinity. Why do I have a parenthesis around this 0? Can we have increase or decrease at a point? Nope. So we always have that in a parenthesis, right? Okay. Now where is it decreasing? On the left-hand side of 0, correct? So, but remember, we do least to greatest. So least is -infinity and greatest is 0. As x is going to the left, as our x's are going to the left, what's happening to the y's? They're going to infinity. As x is going to the right, what is happening to the y's? Good, also infinity. Okay? Any questions? All right, any idea what this one's called? What does it seem like it might be called? Any guesses? That's exactly what it's called. It's called a square root function. Okay? Now, when it comes to time to choose variables here, let's not choose same old this time. Okay? And the reason I don't want to choose same old this time is because do you know the square root of -2? Do you know the square root of -1? Do you know the square root of 0? Okay, it's finally something we know the square root of, right? But just for argument's sake, we're going to go ahead and put in square root of 1. You'll see why in a second. Okay? So how about if for our x values, if we choose numbers that we do know the square root of? You okay with that? So I know the square root of 0. I know the square root of 1. I know the square root of, what's the next one that I know? 4. And then what's the next one that I know? 9? Yeah, okay. So, what is the square root of 9? 3. What's the square root of 4? Square root of 1? 1. Square root of 0? 0. Square root of -1. What times itself equals -1? It's kind of a trick question because you don't know yet. You will by the time we get to the end of this class, but right now, it's undefined. Is that fair? That's a little foreshadowing, something for you to look forward to for Algebra 2. Okay? Alright, so let's graph these points. I can't put anything at -1 because that's undefined, but 0 is 0, 1 is 1, 4 is 2, and 9 is 3. So how is this different than any of the ones we've done so far? It only has one arrow, doesn't it? It doesn't have two. It's not going both directions. Okay? All right, so x-intercept. What's my x-intercept? Where is it crossing the x-axis? 0, 0. And what's my y-intercept? Good. All right, what about my domain? How far to the left does it go? Only to 0, right? So x is greater than or equal to 0. That's my inequality notation. What does my interval notation look like? It starts at the least and goes to the greatest. So it starts at 0 and goes to infinity. Do we need to go over again why this is a bracket? Or do you think you got that? You got it? Okay, awesome. What about range? How far down does it go? 0, and how far up does it go? So is it exactly the same as the domain? Like almost, right? Except domain, we talked about yesterday, are x's and range is y's. So we have to say y is greater than or equal to 0 for the interval notation. Inequality notation is the change of the letters. Interval notation is exactly the same. Okay? Does it have symmetry? No, it does not. Okay? Is there a maximum point? Is there a highest point? Like, as it's going up this way, is it eventually going to start coming down? No, it's not. So is there a maximum point? Okay. Is there a minimum point? 0, 0. Very good. Where is it increasing? As I move from left to right across the page, where is it increasing? So starting at 0, right? So from 0 to infinity. Remember, that's a parentheses because we don't increase at a point, right? Okay. Where is it decreasing then? If it's increasing over the whole domain, where is there left to decrease? Nowhere. Correct. Good job. All right, end behavior. What's happening at the ends of the graph? As x is going towards negative infinity, what's happening to y's? It's going to 0. That's where it's going to end up right there, right? It's not really going to negative infinity because it's going to stop right there, isn't it? Okay? As is x is going to positive infinity, where is y going? Infinity. Okay? Good so far? right, any idea what this one's called? No guesses? Yep, cubic. Because that's a cube, right? The power of 3 is a cube. Okay? So x's, what x's do you want to choose? Can you find the cube of any number? Yes, so is it okay if we do same old, same old? Okay. What is negative 2 times negative 2 times negative 2? Negative 8, good. What is negative 2, or sorry, negative 1 times negative 1 times negative 1? Negative 1. What's 0 times 0 times 0? 0. 1 times 1 times 1? 2 times 2 times 2? Very good. So negative 2 is negative 8. Negative 1 is negative 1. 0, 0. 1, 1, and 2, 8. You think you have a good idea of what the graph looks like? Even better than normal, right? Because these points actually go to the edge of the graph, don't they? Okay? So, like that. What is the x-intercept of this graph? 0, 0. What's the y-intercept of this graph? 0, 0. Good. What about the domain? How far to the left is it going to go? Yes. So that people struggle with that. You know why? Because it's mostly going down. But even though it's still going down, isn't it also scooting to the left? Yes. Okay. So negative, all real numbers first of all. And then negative infinity to positive infinity. So all the way left, all the way right, correct? All right, what about range? How far down does it go? That one seems more obvious, doesn't it? Because it's clearly going all the way down and clearly going all the way up, right? So all real numbers, negative infinity to positive infinity. Good. Does it have symmetry? Can I fold it here? Can I fold it here? Can I spin it 180 degrees? Oh, you can spin it, can't you? If you spin it, what's it symmetric around? The origin. Does that make sense? Highest point and lowest point? None and none. Excellent. As I move from left to right across the graph, where is it increasing? Everywhere. Good. Negative infinity to positive infinity. So remember, moving left to right, it's increasing this whole time, increasing this whole time, increasing this whole time, right? So if it's increasing the whole time, where is it decreasing? Nowhere. As x is going to negative infinity, as we're moving to the left, what's happening to the graph? It's going down, so we are going to negative infinity. As x's are moving to the right, what's happening to the y values? They're going up, so positive infinity. Questions? All right, what do you think this one's called? What was this one called? That's the square root, right? What's this one called then? It's some kind of root, isn't it? Because that symbol is still there, okay? But what about this little baby 3 right here? It is a cube root. That's exactly right, okay? Have you guys seen cube roots before? Okay, so then can I take just a quick commercial break? A square root is a number. You have to think of a number. What times itself gives you that number, right? If I'm taking the square root of 9, I'm like, what times what equals 9? Well, that's 3, right? So what are we going to think about if we're trying to figure out a cube root of a number? What times itself equals that number? Yes, absolutely. Does that make sense? Okay. So the only thing that's going to change really well, let me write this down first. Cube root. the thing that's going to change when I make my table, right over here when I made this table, I said, what numbers do I know the square root of, right? That's what we chose for x. We're going to do the same thing. It's just going to take us a little bit more to think about it, because since you've never seen cube roots before, we might have to think about it a little harder when we fill out our table, right? Now, could I choose -2, -1, 0, 1, 2? Yeah, absolutely, but it's going to be a whole bunch of decimals, and that's not helpful or friendly, right? Okay, so think back real quick to square roots. Could I choose negatives? No, because a number times itself is not ever going to give me a positive. See, how do I want to say this? If negative is what I put in to the square root, what times itself is not ever going to give me a negative. Because anything times itself is always going to be a positive, right? But this is a cube root, right? Can I have something times itself be a negative number? I can, can't I? So, first of all, what's the easiest one that we know the cube root of? 0. Right? Because what times itself equals 0? 0. That's pretty easy. Notice I put it in the middle of the table though, right? Okay? What times itself, what's the next number that I know then? -1. Because what times itself is going to equal -1. Yeah, -1. What times itself do I know the cube root of then? What's the next one? Like, think about what I want this number to be, and then multiply that number by itself. So how about -8? Because what times itself equals -8? -2. Do those numbers seem familiar to you? Well, look. And they're just backwards of what we have here. Another foreshadowing I want you to think about is cubes and cube roots are something called inverse functions. Okay, we'll actually talk about that in the second semester. And inverse functions means their tables are backwards. Okay, so can you tell me the last two that I want here in my x column? Oh yeah, 1 and 8. That was quick, right? That's easy to think about if I know it's just backwards of this table, isn't it? So what times itself equals 1? And what times itself equals 8? 2. Now let's plot those points. -8, -2. -1, -1, 0, 0, 1, 1, and 8, 2. Do you have a good idea of what you think this graph looks like? Good. X-intercept? Good. Y-intercept? Also 0, 0, right? Okay. What's a domain? How far left does it go? How far right does it go? All the way, all the way. So all real numbers, which is -infinity to +infinity. What about the range? How far down does it go? How far up does it go? Same thing. All real numbers, -infinity to +infinity. Does it have symmetry? Can I fold this over this way? No. Can I fold this down this way? No, but I can spin it 180 degrees, right? And if I can, where is it symmetric around? Good. Maximum point, minimum point? None for both, right? Intervals of increase. As I move from left to right across the page, where is it increasing? Yeah, everywhere. So, -infinity to +infinity. If it's increasing everywhere, where is it decreasing? Nowhere, right? Nowhere. As we're talking about in behavior, as x's are moving to the left, what's happening to the y's? -infinity. Good. As x's are moving to the right, what's happening to the y's? It's going up, so positive infinity. Ooh, we're scooting right along, yes? All right, I want you to look at the next two, like, together. Okay? F of x equals b to the x, and f of x equals b to the x. Because that seems like exactly the same equation, right? The qualifier is right after it. In this example, x has to be between 0 and 1. And in this example, x has to be greater than 1. Do you see the difference? Okay? Now, the thing about this is that people get confused. If they're thinking too, like, concrete, they're like, there's nothing in between 0 and 1. Well, you know better than that, don't you? What kind of numbers are between 0 and 1? Say it again? Yeah, decimals and fractions, right? Now, so can I automatically think if x is a fraction, it's automatically this first one? What if x is 4/3? Is that a fraction between 0 and 1? It's not, right? So we just have to be careful. We just have to be careful that x is a fraction that's between 0 and 1. Does that make sense? Okay. So for argument's sake, what do you think is the most popular fraction between 0 and 1? 1/2. Okay. So for this example, we're going to say x is 1/2. Okay. Where is the variable in this? See, this is just the qualifier. Where is the variable in this equation? Because b is not... Can I change something really quick? I just realized that when I typed this, I typed it wrong. Can I fix it? Okay, this should be a b, and this should be a b. Sorry about that. Okay, is it fixed? Okay. So if b is 1/2, answer me this. Where is the variable? X is the variable here, and where is it in this equation? It's in the exponent, right? So what kind of function do you think this is called? Exponential. You notice I left some space out here? Because these are both actually exponential, but we have